Okay, welcome back. You watched the first segment of the video, and then you answered some questions, and now we're going to watch the second segment of the video. Okay, where we left off was Galileo, all right? Remember, at this point, everybody in the educated world knew that the Earth is the center of the universe, of the cosmos, and the planets and the sun, and everybody goes around there. That's what educated people thought, right? And they were pretty entrenched in on that idea. I mean, it's pretty, how can it be anything else? I mean, it's ridiculous to think that the Earth is moving. Just look around. You can't feel it move. It's the most solid thing there is. We build our houses on it, right? Unless there's an earthquake or something, it doesn't move. So anyway, now we get to the beginning of science, of astronomy, and the beginning of modern science. So it starts, we already should have this written down. Galileo, we're talking about 1600 AD. That's, a while ago. I'm not going to be a big stickler for exact dates. I just want you to get a feel of it. Remember Christopher Columbus, 1492. So they'd already discovered the New World, right? But 1776 is the American Revolution. So it's like between those times. All right. So we got Galileo, and something else you should already have written down, that he observed with his telescope. He convinced him Aristotle was wrong, that Earth is not the center. Now, if there's one thing that Galileo liked, it was like knowing something that somebody else doesn't know and kind of rubbing it in their face a little bit. He wasn't necessarily, he was kind of arrogant about it. Let's just call it what it was. He was pretty arrogant. But he had good evidence for it. Now, here's the deal. This is what makes Galileo different. He believed that we know things not because Aristotle says so, not because somebody says so, but because with the evidence of our eyes, with the evidence of our observation. We collect data, and that's what tells us how the world works. That's basically the essence of science. That's what science is you have experiments, and you make observations, and that's how you learn new things, right? Is by observation of the world itself, which, works. But Galileo is one of the earlier people to try that. Okay, so one of the things that he saw through his telescope, he took his telescope and he looked up at the sky. One of the first things he looked up was the mountains on the moon. Write this down. By the way, these pieces of evidence, in years past, whenever I had the test, was name 4 things that Galileo observed with his telescope that convinced him that Copernicus was right and Aristotle was wrong, that the Earth goes around this. So you'll have it in your notes. Write it down. Please cooperate with that, because when you get that question on a test in my class and you don't know it, it's because you didn't write it down. You're going to put it in your notebook. Right. Okay. Mountains on the moon. Here's the thing. The heavens were this celestial bodies, right? It wasn't made of the same stuff as Earth. According to Aristotle, here on Earth we have earth, air, fire, and water, the 4 elements, and they basically, the heavens are made of ether. Ooh, it's a celestial heavenly realm. Ooh, it's not like a place you could go in their view of the world, of their view of the structure of the universe. Okay. Well, the thing is, I don't know if you've ever looked at the moon through a set of good binoculars or a telescope, especially when you get that edge onto the shadow. You can see the craters, and you can tell it's made of rocks. It's got mountains on it. Now this here, look at the quality of these drawings. These are Galileo's drawings. He drew these with a pen or a brush and ink. So he was a pretty good artist too, right? These are Galileo's. You can see what he was looking at when he's accentuating the mountains on the moon. And he's like, whoa, it looks like the moon is made of rock, kind of like it's a physical thing instead of some celestial magic thing, right? So that's mountains on the moon, one set of evidence. Now here's another thing, the moons of Jupiter. This is something that nobody had ever observed because you can't see them with the naked eye. But here's the deal. He'd look up at Jupiter and he'd draw down. In fact, these are his notes that he did. He wrote in Italian, so you can't read it. But this is Jupiter, and then he's noticed these dots that were near it, which you could see with a real good quality binoculars or a telescope. Look at Jupiter sometime with a telescope. It's awesome. And he noticed these 4 dots that were right in a straight line. And he'd look week after week, and they'd be moving around, but they'd stay pretty much in a straight line. And he realized, whoa, what's going on is these things are going around Jupiter. He could predict their motion by assuming they're going around Jupiter. Now, that would mean that there's an example of something that isn't going around the Earth. Jupiter has its own moons. If everything's supposed to be going around the Earth, well, clearly the evidence of his eyeballs says that that's not really true. Something's going around Jupiter. So the moons of Jupiter, the Galilean satellites they're still called. Let me see. They're like Io, Callista, Europa, and Ganymede are the names of the 4 moons of Jupiter. If you ever do a report on Jupiter, he's the one that discovered him and he's the one that named him. Okay? So the moons of Jupiter. Another thing, the phases of Venus. Now, this was the real kickoff, right? We're going to be learning what causes the phases of the moon. And I'll just tell you, it has to do with the direction of the light that you see it from, right? Part of it's in shadow, part of it is illuminated, and the direction of you and the light and the object you're looking at. And look at these pictures. He didn't draw these by hand, but they were in his book that got published. They were a plate, And so, here you have, what planet do you think that is? Saturn. But by the way, Saturn's visible in the night sky nowadays. And here's Mars, and here's Jupiter, and here's Venus. Now, the thing about Venus is sometimes it's brighter than other times. It's always visible either in the morning sky or the evening sky, right? You'll never see Venus directly overhead. Won't happen. And then people are like, why is that? Well, I don't know. Well, it turns out the reason is Venus is inside of our orbit. It's closer to the sun than we are. So you're never going to see it on the opposite side of the sky from the sun, right? Okay, so anyway, sometimes Venus appeared like this, smaller but fully lit. And other times it would appear bigger, but here, lit from the side. It had to be lit from this side here. This side is illuminated and this side is in darkness. Okay, now if this side is illuminated, this side's in darkness, this means that the sun is actually on the other side of Venus. If you ever see it where it's larger and all it is a crescent shape, that means it's being lit from the back, from our perspective. Here, that means that the sun is on the other side of Venus. Here, it's being lit from the front. That means that the sun is on the same side as us, as Venus, to light the full face of it, to light it up. So that means here, Venus is on the other side of the sun, and here, Venus is on the same side of the sun as us, and that's impossible if we're in the middle and the sun is going around there. The only way you can have them like that is if the sun is in the middle, we're going around, and sometimes Venus is over here between us and the sun, and sometimes it's opposite us and the sun. Now, it'd have to be over here. You can't see it directly behind the sun because it would be daytime. Okay, so anyway, that's the thing. The phases of Venus was the real kicker where he figured out it has to be the case that the Earth is going around the sun. The sun has to be the middle. Again, if you were kind of like, what? I didn't quite catch that. See if you can visualize what it is. But again, the key part is his observations with the telescope taught him or convinced him the obvious, truth must be that the sun is in the middle and the Earth is going around the sun. Okay? Now here's the deal on this. Faced the Inquisition for his heresy. His heresy means this was a belief that you're not allowed to have. You're not allowed to believe that. Now, here's the thing. Think about it. He lived in Europe during the 1600s. What you know about American history, the Pilgrims were coming to America. They had to move from Europe, where there was civilization and stuff, to a wilderness and carve out an existence. And now, what was one of the main motivations for the Pilgrims to come to the New World? You know this. Now, this isn't the case for everyone, but a lot of them came, the Pilgrims, seeking religious freedom, right? America was founded, the idea of that, you can believe whatever you choose, right? And the government, the official people don't have anything they can say about it. You have the right to believe what you want is one of the foundations of America, because the Pilgrims were escaping religious persecution. Because in Europe at the time, if you had an official religious belief, anybody who believed something different could be persecuted drastically. They could face the Inquisition. That's an inquiry about whether you believe in these dangerous and false beliefs. He ended up being condemned to house arrest, which meant that he could never leave his house again. He was condemned to stay there, never to go out and leave, and never to discuss this kind of thing at all ever again. So anyway, make of that what you will. I'm going to tell you, though, when we get to the lesson, he ended up winning out, not in his lifetime, but science won out by not just figuring out that the Earth goes around the sun, but how it works. Why can't we feel it? Now, that was part of the people's arguments against, the Earth going around the sun. It's like, what, are you crazy? How could the Earth be spinning around that fast? We'd be flying around and stuff, and we didn't feel it. Nobody could really believe it's a crazy idea, but it's true. And so it wasn't until another scientist came along, a guy named Isaac Newton, and he's going to be the next lesson, because he explained how it works and why we can't feel the motion of the Earth. In fact, it's kind of fun sometimes to watch a sunset or something where you see the sky or see the moon moving behind a branch and try to picture, it's the Earth is spinning. It ain't easy to do, but it's true. Okay, so we're going to get back to that next lesson. See you then.